verify that I'm online. Um, the live has not started yet. I don't know why. What's going on? What is going on? Okay, so how about here? Not sure what it is, but let's see. Um, okay. My stream is working, so I'll just put that aside and sometimes these things can get funny. Oh, okay. Um, all right. So today we are going to. I'm just going to revise a lot of things today. This will include everything I've done so far on LinkedList, how to implement a linked list and so on, right? So I'm just going to do that and then solve two questions. Um, Whatever I'm going to do today is just like a foundation uh, on top of which uh, those the two questions I'll be solving uh, will be based based on, right? What did I just say? So let me just increase my time. Uh, I'm not sure I'll finish all the 1 hour 20 minutes today, but let's see. Let's take it one step at a time. Hello? Sorry about that. I had a call and I had to pick the call. All right. So where are we? Oh God, this is good. Let's take let's take it one step at a time. So, in the description, I planned to implement a linked list, right? And uh, I want to show how to implement a linked list. I want to show. Oh God, what's going on? I want to show how to implement a linked list. Also, uh, how to print nodes in a linked list, or how to print a linked list, basically. How to print a linked list, how to reverse a linked list. Those three topics will help us, solve the two questions that I've set for today. All right. I'll just clear my board. Uh, thank God I haven't started, but damn. Okay, sorry about the breaks. Um, Now I'm good to go. So let me quickly show you the lecture for today. Right, this is for you know. Um, I think the purpose of this is to actually, I won't say, is to memorize, right? Is to like enforce that knowledge of a certain topic in your head. Something repetition helps you retain it, right? So, which is why I'm going to. I've been doing this for like the past three, 4 videos. I've been repeating linked lists over and over again. But yeah, I'm going to do that today still. Um, God, my internet is just bad. Okay, enough of the complaints and let's start. So we know that a linked list is made up of nodes, right? It's just like an array with a lot of nodes in it. Let me shift this to this other screen. It's just an array with a lot of nodes, right? And each node is connected to the other node through a property called next. So let's say this is our linked list. So our linked list is like this. So I'll put oh, that's very small. Something like this, connected, connected, and we'll have our values in it. 1, 2, 3, right? And this one should be none, right? The last node, which is the tail of the linked list, always point to none, because the property of the node itself is such that, so this node in a much broader view will look something like this. So it's a class, right? It's an instance of a node class. So it will have, first of all, it will have a property called data, or in some cases it's going to be value, right? Value, and this value will be this value here, this one here, one, and it will have another property called next. Now this next is initially none, but when it is part of a linked list, it might be the next node, right? So this could be none, or it could be another node, right? So this here is a node, this is a node, and this here could be, this next property could have a value of none or another node, like this, right? And this node too looks something like it will have its own data or value, right, set to 2, and then this 2, the next of this one will point to another node, right? This node is going to be, I'll just put node of 3. So that is what a linked list really is in a much I'll say on a surface level, right? If we're to implement a linked list, right, it's going to be like this. So basically, we'll represent, first of all, we'll create a class called node, right? And that class is what we use to insert value to our linked list. Again, a linked list is made up of nodes, right? So for us to create a node, we need to create an instance of a node class. So let me show you how we'll do that. I'll bring this back here. So here we have a playground, and I'll use this to create my my node and linked list, right? So I'll say this is going to be class. I'll call this since GitHub. I said GitHub. What's it called? LeetCode. Yeah, LeetCode uses list node, so I will just use list node instead, right? Or you know, just to avoid confusion, right? I'll just use node, and then set the node. So since we are going to be creating instances of this node class, we need to, create a constructor, right? So I'll say define, so the init method, right? Now, we said our node class is made up, it has two properties, right? So to set those two properties, we'll do self dot value, right? And this value is going to be a value we'll pass to our node class when we are instantiating the node, right? The node class. So which means if we are going to pass it a value, then we'll have to pass the value here. So self, and then we'll put value here like this, and then the next value, so self dot next, which is equal to none, right? This will be none at first. So that's how you create your node class, right? And this node class is what is going to help us create that connection, right, between a lot of node in order for us to create a linked list. So let's create our linked list class. I'll say class linked list, right? Sorry, linked list, and we'll say since we are going to instantiate this linked list class as well, we'll create a constructor. So there, and yeah, our linked list does not, we don't pass values directly to the linked list. Instead, to add values to our linked list, we add the values through a method, right? A method of this class. So at this point, I'll just say linked list. Our linked list will have two positions. So let me come back here. So first of all, one of the aside the linked list being made up of nodes, one of the most important features in a linked list is the first node in the linked list. The first node is known as the head of the linked list or the list. So this is the head, and the last node, right? The last node is our tail, and that node usually points to none, right? So let's go ahead and, so since we know our linked list is going to have a head, so I'll just put a self dot head, and set this head to none, right? Which means we don't have anything in the linked list to begin with. So now let's create a method of this class to allow us to add items to or nodes to this linked list. So to do that, I'll call this function I'll define add nodes. Let me call it add node like this, and this add node function is going to accept the value we want to add to our linked list, right? Now with this value, we'll create an instance of our node class. So I'll call this new node is equal to the node, and then we'll pass it the value, right? Now, so before we add an item to our linked list, we need to first of all verify if there were existing nodes, but before that, we need to first of all check if we have a head already in the linked list, right? So I'll say if our head, right, if the head, sorry, self dot head, if self dot head is none, right? If self dot head is none, then we want to set the self dot head to the current node that we just created. So I'll just say self dot head is equal to new node. Now we just return, so we know that that's one operation. Now in the case where the head is not empty, or in other words there is already a node in our linked list, then we'll need to traverse the node up to a point where we find a node that has a next value of none. In other words, if I added 1 to my linked list, right, if let me just come here. So what this operation does is, so I have a linked list. I'll call this linked list, I'll put it like this. Let's say it's just an empty okay, let me say L, right? Linked list is just equal to nothing, right? And I created my first node, right? My first node like this. So let's say I want to pass 1 into my linked list. I want to add 1, or a node with a value that is equal to 1 to my linked list, right? So I need to first of all instantiate the node, right? I need to create an instance of the node class and then add that instance or replace that instance to whatever is here, right? In the case where this linked list has nothing, right, or in other words, when the head is empty, right, the head at this point will be equal to none, right? This head will be equal to none. This pair head, well, this head will be equal to none. So since the head is equal to none, we will just directly add this node to this linked list like this. So I'll just say node, right? To add the node, we'll simply do self, right? Self dot head, or okay, let me just say we'll just set the head, right? We'll set the head to be equal to this new node. Now the linked list will become something like this. So it will look like this. So initially it has head equal to none. Now since the linked list starts from the head will look something like this. So we'll have a data that is equal to 1, or whichever value we're passing through the instantiation phase, 1, and the next value here is going to be equal to none, right? Now to add another item to our linked list, we need to first of all, so I'll put node here, node 1 like this, and this will have just none. Okay, let me not put node. Instead of putting node, I'll do this. I'll say 1, right, and then none. Now this entire thing can also be represented as 1 and none like this, which is why I represented it this way. So for me to add another node, let's say I want to add a node with a value equal to 2 to our linked list. For me to do this, I need to first of all check if there is already a node in the linked list. Yes, there is a node, but what is the next value of that node? I need to get the next value of the node, because at the end of the day, my linked list is just made up of nodes connected to each other through their next property. So since the next value here is none, right? Since the next value here is none, I'll simply take this none, I'll replace this none with my new node, right? And my new node is simply going to be equal to 2 and then none, right? 2 and none. So I'll just do 2 and then none, right? Now let's say I want to add a third node, right? I'll say node 3, right? So this is my linked list here. So for me to add another node to this linked list with the way it's already looking, so this is head, and the head has the next value, which is another node. For me to add another node to the end of this linked list, I need to traverse the linked list from the beginning. I need to traverse from the head all the way to a point where the next value of a particular node is equal to none. And only then I will be able to take this value here, right, this new node that I want to add to the linked list, and add it at that point. So I'll just replace this. So I'll just come here, erase this value, and then add the new node to it. So this is going to be 3 and then none. Now, as you can see, it took us 2 steps to add a new item to our linked list. So the insertion of a value into a linked list is O of n, right? Because you need to traverse a lot of nodes, or nodes that that are already connected, up to a point where there is no connection, or in other words, the value of a particular node, the next property of a particular node has a value equal to none, and then that is the point where we insert our new node. So let's go ahead and implement this. So we'll first of all traverse our node, but we'll set our node to we'll say current node. Now this current node is simply going to start from the head, right? Since we are traversing the node, self dot head, right? Since we are traversing through the entire node, and we'll say while the current node is not empty, right? I'll say is not none, right? While the current node is not none, we want to set the current node to the next value. Current node is equal to current node dot next, right? And then if we finally get to a point where we find a node that has a next value equal to none, right, we'll know at this point the insertion would have, this loop would have stopped running, because we found a node that has a next value equal to none. So we'll take that node, right? We'll say current node dot next, right, is going to be equal to our new node here, and this is how you insert a value into a linked list. So now let's see how we can print out these values. So I'll just define a function called print. You know what, I would like to have the function outside, because I might define other functions that will not belong to. Okay, you know what, let's do it this way. Now let me put it outside so I can easily, it's nothing to define it inside the class itself, right? Because I can just do that right now. You say define what do you call it, define print, I'll call this print list, right? Print list. We'll simply, since we are already in the class, we don't pass it ahead, so I'll say current node is concurrent. Current node is going to be equal to self dot head, right? Self dot head, and we'll iterate. So we'll say if the current node, while current node dot next is not none, right? Is not none, or we can just say while current node dot next, right? While current node dot next, this also works. We'll just say print the node, right? Print current node dot next, current node dot data, and we'll just say we want to print everything in a single line with an arrow in between, and then we'll set the current node to the next node dot next. So that is how we'll print a value in a linked list. So let me just I'll create an instance. I'll say new list is going to be equal to our linked list So since we are instantiating, we do it that way. And we say new list dot add. We want to add a node, right? Add node. We want to add one, and I'll add about 4 nodes. One, yeah. So I'll say 1, 2, 3, and then 4, right? So let's print this linked list. So I'll say new list dot print the list. So let's run this. Okay, so we have an error here. It's a current node dot next is equal to new node. Where is that? Current node dot next. Do I have a next? So a non-type has no attributes next. Oh, you see, while current node is not none, right? I don't know, I keep making the same mistakes. Let's see. Current node dot next is equal to new node. So we already reached here. So we set the current node, we set the current node to the new node, right? So we don't have anything because the values are not being added. Let's see. Current node. Yeah, we set the current node to the next value, right? And then we can just do current. Hold on. You see, repetition is very good. So try and repeat. If you can memorize, it is allowed. So let's see. I've done this here, but so previous node, next node, yeah. I mean, oh, you see, this is what I was missing. Okay, so instead of this is my fault, and I'm not going to repeat this mistake again. So when this, we have to know that the next value is not none in order for us to add a value there, right? This is where we need to do this operation, and we'll now say if the current node here, right? If the current node, then we'll just do this. There's still node dot data. What do I call this? Oh, node dot value, not data. Okay, my bad. Node dot value, right? Okay, no more errors. You see, repetition is good. All right, so I added these nodes. Now you can see the linked list is output is in the console here, which is really awesome. So that is how we print values in a linked list, right? And so the next thing to do is what did I say will be next? So print a link. How to reverse a linked list. Whoosh. This one is very interesting because this is the part where it requires a lot of attention to details in order for you to be able to reverse a linked list. So to reverse a linked list, right, we simply need to do this. We simply need to take the linked list. I have two chats in the comment section. Okay. Hello. Who's that? Comfort. Oh, thank you. And there is engineer. Welcome. I think I remember you from yesterday. Yeah, you showed up. That's good. So let's carry on. with reversing a linked list. So how do we reverse a linked list? Where did I drop the pen? Oh my god. Okay. Right. So how do we reverse a linked list? Well, reversing a linked list involves three steps, right? First of all, we need to start from the head, right? We're always going to iterate from the head. Basically, if we had a linked list like this, if we had, one, two, three, and then let's say the last one here, right? The reverse of this linked list should look something like this. So it should start three, two, then one, and then none, right? So our head becomes the tail, and the tail, which was previously our tail, becomes the head, right? So let's see how we're going to do this. So how can we reverse this linked list? Well, for us to do this, it's quite, you just need to you probably need to see this to be able to do it, right? So first of all, we set a previous value. Since we know our previous value is going to basically be none for the first head, right? So we need a previous value, and every node, right, every node that is inserted into the reverse becomes the previous, right? And then the next node becomes the next node of the current node, right? So let me show you what I meant by that. So let's say here now we start with this head. This is our head, right? Our head is equal to 1. I'll set it like this. I'll say, head is equal to 1, right? And then the previous, right, the previous value of this head, we know it's going to be equal to none, right? So we'll just say previous is going to be equal to none. Now we'll begin traversing the linked list from the head, right, this point all the way to this point here, right? So how do we do that? Well, we'll say while we'll run an iteration. I'll just put a loop here like this. This is going to be a loop, and then we'll start. When we see this head, right, this is going to be our head, or the current node, whatever we set it to. We'll set this head. The next value of this head will be this previous, right? And the head itself becomes the next value here, right? So again, we'll probably need a placeholder, or I'll call this next node. This is going to be next node, right? Next node is simply this node here. The next node is simply the node on the next side of our head, or of our current node, right? And then we'll just set it. So this is going to be equal to 2, right? And then we'll take the previous, we'll set the previous now, previous to the current node. The previous will be the current node, because this previous, right, this previous will act as the next value of this node here. So we'll set as its next, and every time the previous node becomes the next node of the current node. So the previous is simply going to be equal to the current node, or the current house. Instead of this being the head, right, I'll call this current. So this will be current, this will be current, and then current node, right? And then only then we can now set this current node here, current node dot next, right, to be equal to what? To be equal to this previous. Oh, we would have done this first. We would have set the current node dot next to the previous before we reset the previous to the current node, right? Otherwise, this would have changed at this point, so we don't want that. We want to still keep it as none. Let me just show you this in code. So let's define a reversal function. I'll say so define reverse linked list, and I will create so I'll accept a head, right? This is going to be a head node, and what else? So let me just quickly type this. I'll say this is going to be an instance of a node, right? Like this, so that I'll have all the properties there. So the first thing to do is I'll say current node, current current node is going to be equal to our head, right? It's going to be equal to this head, right? And the previous value is going to be equal to the current node. Oh, sorry, it's going to be that's the previous for this node. So the previous is going to be none at first, right? And then sorry, and then we can begin traversing the node, right? So we'll say while there's still nodes that have good values. So while current node, right? While current node, okay, I can say while not none. This also works, or while current node, whatever. Both still works, right? You can do while current node as well. So I'll just keep that there. While current node is not none, right? Then what do? We first of all take a copy of this current node, right? So I'll say this current node's next value, because it's going to be our next node. So I'll say next node is going to be equal to the current node dot next, right? And then we'll say this this current node, right? Or we'll say the previous node should be equal to the current node, right? The current node, and then we now begin to reset this current node. So I say current node dot next should be equal to previous node, right? And then we'll set the current node to the what do we set to? Okay, we set the current node to the next node. So yeah, and that's all we need to do to reverse a linked list. At the end of the day, we need to return something, right? We'll know at this point, since we set the previous node to the current node instead every time. Sorry, we'll just return the previous value. So previous, return previous like this. So what do we do? This is why I said I didn't want to put this function here. So I'll just take this, right? I'll remove this from there. I'll put it here. Oh, come on. So I'll remove the self and add in a head, which is going to be a node, because I want to use this function to print out all my so this is going to be the head, right? Head, and then we'll just do this. This will work fine. So this will no longer be here. Instead, we'll just pass it the new list, right? New list dot head. Yep. So let's run this. Now you can see we still have our linked list here. So let's print out the reversed version. So the reverse will simply be, we'll pass it the head, right? So since we are returning a value, we can store that in a variable. So I'll call this so let me do it here. I'll say reversed list is going to be equal to reverse, what do I call this? Reverse linked list, right? And pass it the new list dot head, right? And then I'll just print reverse, no, not print like that. I'll say print list reverse list, right? Reverse list So we don't need dot head because we are returning the head itself. So what's here? Hold on. What? Yeah, I mean, I've said this. Okay, let's print this and see what. So there is an error, and you can see, oof, that is bad. So um, here's what I did. I think I did something wrong here. So the current node is equal to the head, right? So if the current node is not none, right, set the previous node to the current node, previous dot next. Current node should be equal to this, but the current node dot next is previous value. Current node return. So let me just take a look at what I did here. So you said, I mean, yeah, I did that, right? I said the, oh, this is my mistake. I was setting the previous, yeah, it's supposed to be like this. I needed to set the current node next value to the previous before changing the previous node. So let me separate this a bit. So I'll just print an empty string here to just add a new line to this. So now you can see we have our original linked list like this, and this is the reverse form of it. So yeah, so that's how we reverse a linked list. That's how we create a linked list as well. So repetition would, repetition will make you remember very well, which is why I am repeating this. And I'll make sure every day I at least implement a linked list in the morning, reverse the linked list, and do it. I'll just do it every day, every day until it becomes part of me. Okay, so in the chat there are, okay, hi, hi Rohit, and best of luck. Oh, thank you, Sulat. All right, so let's go ahead with another question. Um, so I will. What's the next thing on the plate? What's the next thing on the plate? So the next question is this one. Let me move this to this side. So we are going to solve this one, which is supposedly an easy question, but let's see how it goes. Given a linked list, right? I was supposed to do revise how to access an item in the middle of a linked list, right? There are two ways to do this, but um I think I have one way that I really like, which is the fast and slow. I think they call it fast and slow, you know. So the idea is you have two pointers, right? One pointer will move faster than the other one, which is, you have, let's say you have a node like this, you have a linked list like this, right? So I'll put, 1, 2, 3, and then none, right? Or let's say, forget about the none, let's say 4. Or, yeah, 4, 5. Now, in order for us to get the middle of this node, we'll first of all start the pointers, or the fast and slow pointers, right? So this will going to be fast. The reason why it is called fast is just it moves a step faster than the slow pointer, right? So this is going to be the head. They are both going to start from here. I'll call this S and F, right? They are both going to start from here at first, but when the iteration begins, right? When the iteration begins, the fast node will move 2 steps faster than the slower node. So F, let me just do this. Let me put S and I'll put F like this. So in the first iteration, right, the first node is going to be here. It's going to move next, next, and next, right, while this node is still here. Now, in the second iteration, this would have moved next and next before this will move to this point here, right? So, and in the third iteration, before this becomes false, right, this would have moved to this point, right, before this will just, okay, it will point to none and the iteration will stop. That's the idea between that's the idea for the fast and slow pointer. So you start from a point, right, with a slow pointer, and a fast pointer will move faster than the slower one. So you have, at the end of the day, you always end up in the middle, right? The fast pointer would have moved all the way to the end of the linked list, right, or of the nodes, and here you will have your your slow node here. You will have your slow node at this point. So every time, for every 2 steps this fast node makes, right, so we will be here 1 2, this will make 1 step, and this will go 1 2 again, right, this will make another step, right, and we'll end up in the middle at this point. So this is how you get the middle of the linked list. So let me just show you how we can do that. So let's say get, I'll say get middle, get middle, uh, get middle, and I'll pass this a head, right? Always we want to start from a head. This is going to be a node, and what do? We just take the next value, right? So I mean we start with a slow, so this is going to be slow. Slow is going to start from the head, and fast is going to start from the head as well. Now this is what we do. We'll say while there is a fast, right, and fast has a next value, fast dot next, right, fast dot next, then we want to increment the fast by 1. I mean, we want to increment the slow, so we'll say slow equal to slow dot next, right, yeah, and then the fast becomes fast, since we are moving it 2 step, next and dot next. So at the end of the day, we'll just return the slow node. So slow, return slow. Alright, so let's print this and see what's inside. I'll use the linked list we created before, right? So this is going to be, what's the middle of this node now? We have, so it'll probably be, I don't know, 2, right, because this would have, they'll be here, right, so 1. To even make this easier, right, let's start with a node with a single value in the middle, right. I'll just do this so that we actually see what's going on. So for every 2 steps the first pointer makes, right, will move the slow by 1. So let's see, reverse, I'll print again another empty part just to add an empty line in between my print statements. This is not an operation, so don't worry about this. So here we have reversed. So we want to, so since we are returning, this slow is just a node, right? So I'll take this, I'll say print, so I'll say, what do I call this? Okay, the middle node. I'll say middle node. Middle node is going to be equal to the middle, get middle of a certain node or head. So I'll call this new list dot head, right, and I'll print list and pass it this middle node here, right. Hopefully you see, so there is nothing being printed, uh for certain reasons. Let's see what's going on. So print link this. This is the. Wait, did I just hold on? So you can see. Oh, I've already reversed this link this. Wait. So. You know what? Let's remove the reverse parts. I want to see this properly. So now, now you can see, the middle started from 2, right? So the middle is from 2 all the way. So yeah, it works. It works. So based on everything we've done so far, we can then, so when we reverse the link, why is it not taking 2 all the way to 1 instead of 1? I'm not sure why, but there should be an explanation for this. So we've seen how to reverse the linked list. We've seen how to get the middle of a linked list. Now, let me read this problem. I think I might be running late to somewhere, but I'll just try. And okay, let me see the chat. Yeah, I remember you. I mean, you've always showed up, which is really nice. I really appreciate that. Okay, so let's see if I can do one more question before I leave. So we'll see that now. Oh, guys, I just hit 500 subscribers. Thank you all for subscribing, and this is really nice. Thank you. Okay, so let's go ahead and solve this question. So we are given the head of a singly linked list. Oh, this is very small. Oh my god, I did not even increase it. Sorry. So here we go. So we have. Was this small as well? Wait, I don't think so. Yeah, I'd already increased it, so we are good. So we are given the head of a singly linked list. We want to return true if it is a palindrome, otherwise false. Now there are 2 ways we can do this, right? I think I should just explain this. Maybe tomorrow I will implement the code. I am really running late for somewhere I'm going to. So we have a linked list, right? And we want to prove if the linked list is a palindrome or not. Now, a palindrome will be such that the reverse is the same as the original list, right? So every item in the beginning can appear at the end and it will still read the same, right? So let's take a look at this example here. So we have 1, 2, 2, and then 1, right? This is a valid palindrome, right? Because when we look at it this way, when we reverse it, or when we try to, when we compare the reverse form of this, let me just do it this way. This is going to be 1, 2, 2, and then 1, right? The reverse form of this is still, let me just do it in a different color. 1, right? This will come to the front, this will come here, this will come here, and then this last one will be here. It still reads the same, nothing changed, right? But how do we solve this in terms of linked list operations? First of all, we did some operations that could actually help us. Now, one way to do this is to reverse the linked list, right? You can reverse the original linked list and compare the values, at each point, right? You can compare these 2 values, right? You just take 2 heads, right? Traverse the heads, right? And compare the values at those points. Or another thing you can do, right? To just, an optimized version is to is to take half of the linked list, right? Just take half of it, right? And compare the values, right? Take half of the linked list, reverse this, and then the value of this here, right, should be the beginning, and the value here should be this one here. If you reverse, if you had two nodes, this one is a linked list with identical values in the middle, right? Let's say we had 1, 2, and then 1. The reverse form of this will still be 1, 2, and 1. But how do we prove this? By taking half of the linked list. It'll still be the same thing. We just do 1, 2, 1, right? This will be our original, and this will be the reverse. I will say this is reverse half, right? Because we are just going to take half of this and reverse it, right? So we are going to take half of this and reverse it. Half is going to be from here all the way here, right? So the half here is going to look like this. It's going to look like 2, 1, right? 2 to 1, and our original list is still going to be the same. Now, how do we do this comparison? The comparison is going to be such that we are going to loop based on the amount of node we have in our reversed half, right? So our reversed half is going to be like this. So while the reversed half, right, we want to compare the value at each point, right? This is not the reverse form. The reverse form will be like this. Sorry. I'll just put this is going to be equal to 1 and then 2, right? Instead of reversing the entire thing and comparing each value, now we just reverse half, right? We'll short it to half, reverse that half, and then compare the value at each point. So we'll compare this value here to this one here, and this one here to this one here, and they'll be the same. And by the time we compare the last values, right, we'll reach the end of this half, this reversed half, and then we'll just return true. Otherwise, when we find a value that is not equal, right? So let's say we have an original list that is equal to 1, 3, and then 6, right? So when we reverse half of this, right, our reversed half is going to look like this. It's going to look 6, 3, right? And maybe none here. This one will have none. So we'll begin to iterate and compare the values. So we'll say for the reversed form, right, we want to get the head. The head will be this, right? This is the head of the reverse form, or whatever you want to call it. The previous while you were reversing it. So this head, right, is the value of this head the same as this original head? In this case, it is not, so we immediately return false, right? This will be much more optimized than reversing the link, right, the linked list, and then comparing the values afterwards. So when you look at this, right, you see everything builds on top of each other, because we did this here. We learned how to reverse the linked list first. Create a linked list, print values of a linked list, reverse the linked list, get the half value in the linked list. So with all the knowledge here, we'll be able to do we were able to perform every step in that other solution, in that other problem, to be able to solve it, right? So I think that's all. I'm really late, so I'll need to go now, and I'll provide the answers tomorrow for these questions. See you. Bye.